Hello and good morning. My name is Asif Parker and I am a HM Specialist Inspector of Occupational Hygiene working for the Health and Safety Executive. And today my talk will be on working safely with solvents. I would like to thank you for inviting us to this event today and being able to speak here today, and building that relationship. Building those close relationships will mean that we go forward in the future and build and get a good understanding between the two parties. So what is the role of an occupational hygienist? Well, what we do is we recognise the hazards, evaluate and control the risk to health. So we look at different environments, assess what we can do, understand the environment and work in such a way to try and reduce exposure as much as we possibly can, usually trying to prevent ill health. That's the fundamentals of it. So areas and things that we look at: solvents, anything to do with exposure to various hazardous substances. We look at things like noise, vibration, asbestos, Legionella. But today our focus will be on working with solvents. My experience, I'm actually quite new to HSE. I've only worked at HSE for just over 6 months now, so please do go easy on me when it comes to the questions. I do have moral support here today, and prior to that I've worked in consultancy for over 8 years. So if you could save the questions to the end of the presentation, that's when we can have a discussion if you have any questions in relation to the presentation today. So what are the health hazards of solvents? There are a lot of hazardous substances that we are exposed to within the workplace, and we are moving to cleaner solvents within the workplace, but we will be talking detail in relation to these. We'll also be looking at the health risks. Some are carcinogens, some have various properties, so we'll be talking to detail about those. We'll be looking in detail about the hierarchy of controls, looking at things like substitution. Do I really need to be using this substance? We'll be looking at elimination and looking at other options which are available out there to us within the workplace. Fundamentally, with solvent degreasing, we will be looking more specifically within the degreasing area today, and I'll be using a prime example of open-top degreasing. We'll be looking at working methods in ways in which we can reduce exposure, look at control and good working practices with those. And finally, what we've got is a case study to wrap things up today. Within the case study is a experience of one of our inspectors who is local to our office, and we'll be looking at specifically what the outcome was, looking at the bad practice and looking at what we could have done in that instance to improve the situation. Okay, I'm sure you all know what solvent degreasing is, but briefly, solvent degreasing or solvent cleaning is the physical process of using organic solvents to remove grease, fat, oils, wax or soil from various metal, glass or plastic items. Historically, there are 5 main types of degreasing, one of which is hand degreasing. That is the application of a solvent by hand, removing during the cleaning process. And then you've got the 4 main areas which I'm sure all of you know a lot about. So we've got cold cleaning, open-top vapor systems, conveyor systems and enclosed closed systems. Cold cleaning, generally speaking, this solvent is cold and then you apply the product within the area itself. And then more commonly you've got vapor degreasing, which applies to open-top conveyor systems and enclosed and closed systems. However, you can have closed cleaning systems which are used in the conveyor form. What we are starting to see a lot more of within the workplace, which I've been advised by a lot of inspectors locally to me, is within the industry you're tending to find that a lot of organisations are moving to closed systems. And that's a good thing because obviously you are reducing exposure, reducing occupational exposure levels. There are also many benefits of doing that as well. What we've been advised is that there is higher productivity, and also we've been advised that the plant itself lasts actually a lot longer, duration of use. And also, more importantly, is you're using less and less solvents as well. So that is a good change within the industry itself. When you do decide vapor degreasing is what you should be doing and is the preferred cleaning method in that instance, though, you need to understand ways of improving the plant potentially that you currently have. So we'll be talking about areas where we can improve plant later on in the talk. Obviously, adopting good practice. There are a lot of things that you can do which could reduce exposure within the workplace. And also, fundamentally, you need to examine the benefits of using modern day plant. Because obviously, you might have plant in place, but it might be far more beneficial in terms of reducing the risks, health hazards in implementing a newer system within the workplace. Okay, so common solvents that we potentially use within the workplace. I mean, the most common ones there are your chlorinated type solvents, and these are things like your trichloroethylene, dichloromethane, tetrachloroethylene, and also N-propyl bromide. They're probably the most common types potentially used within the workplace, and we are trying to phase these out as far as we reasonably can. These are also the most hazardous types of substances that we are potentially exposed to as well, so that's why we are trying to phase these out. In terms of routes of entry, the most prevalent type of entry is through inhalation, so that's through breathing, and obviously that is dependent on the health effect is dependent on the substance itself, so the known health hazard of the substance itself, the amount you're potentially exposed to within the area, so the concentration of that substance at that given period. Obviously, if you are working in a confined space or if you are working in a poorly ventilated area, then the potential exposure within the area will be far greater. And also the length and frequency of the exposure itself. So if, say, for example, you are working with trichloroethylene within a confined space and you're working in that area for 8 hours on a regular basis, you're more inclined to get that health effect, which potentially could occur. Other routes of entry which you must consider when exposed to solvents, obviously some solvents can be absorbed through unbroken skin, and when that occurs, then that then can be transferred to target organs within the body. And also, you can actually get contact dermatitis from exposure to certain solvents as well. And the other route of entry which we must talk about is ingestion. This is probably the least common type of route of entry, but there is the potential for it to occur. With ingestion, what we've tended to find within the workplace is, say for example, someone has decanted a solvent into an unlabelled bottle. What then occurs is, accidentally, someone might go and drink that bottle, and then as a result, they've potentially ingested that substance itself. So if you do ever decant or transfer any solvent in any container, ensure it is clearly labelled. So there's 3 main areas of concern with health hazards and risks. Situations which are immediately dangerous to life. So these are scenarios where potentially you might have unconsciousness or asphyxiation, which potentially could lead to death. So we will be talking in more detail about this in the following slides. It also might be as a result of bad working practices or confined space work. A lot of open top degreasing tanks, potentially nowadays, they are quite large. So when, say for example, you are going into the area to maybe clean out the degreasing tank, you will be exposed. The area itself could be defined as a confined space. And what we'll also be looking at is short-term acute effects and long-term chronic effects, which I'll be talking about in the next couple of slides now. So, with degreasing, there have been serious incidents which have occurred. So, what you need to take into consideration is when degreases are being maintained. This has been the case even with enclosed systems. So, if you are involved in enclosed systems, do ensure that you do have the correct procedures in place. You should always have good working practices, standard operating procedures in place when undertaking any of these types of works. You should also, this has also occurred when tanks are being cleaned out. So if you are cleaning open degreasing tanks or any form of tank, do ensure that you do have the correct measures in place. When solvent is being replaced is another big problem that we have within the workplace. What you find is actually when you add, say for example, hot solvent, which is within a hot degreasing tank, is that solvent will quickly vaporize within the air itself, causing an extremely large exposure to that potential substance within the area. So in essence, you're getting a very high exposure very quickly. So deaths have actually occurred as a result of that. Emergency rescues. This is also a very, very important point. When, for example, say for example, there's been an incident within an area, you need to ensure that you have safe working procedures in place when involved in any rescue, or it might be, say for example, a large spillage. You need to ensure that you have the relevant cleaning procedure in place in those instances. Also, other scenarios, deaths have actually occurred when leaning over open-top tanks, and also replenishment activities. So I talked about how when cold solvent it has been added to hot solvent, and how that quickly vaporizes within the air itself. Generally speaking, acute effects are short-term effects. These effects generally occur straight after exposure. Common types of effects with solvents are dermatitis. You've also got defattening of the skin. We've got an example there showing dermatitis as a result of exposure to solvents. You've also got various narcotic effects. So this is dizziness, nausea, headaches, fatigue as well. And what I'm going to talk about in detail here is exposure to dichloromethane, because this has been an area which we've seen a lot of incidents occur recently within the workplace. So dichloromethane itself, within a poorly ventilated area, is being exposed to small amounts. What we've found is it can produce very, very high concentrations within an area very, very quickly. And there have been a lot of instances there have been some instances recently whereby exposure to dichloromethane has actually led to the death within the workplace. So with dichloromethane itself, it basically can be readily absorbed through the lungs and distributed around the body, including the brain itself. And basically, inside the body, what happens is it's metabolized into carbon monoxide and carbon dioxide. And then the carbon monoxide itself preferentially binds to the hemoglobin in the red blood cells, forming carboxyhemoglobin, which then interferes with the uptake of oxygen. The other thing with dichloromethane as well is it can cause central nervous system depression, and this can affect both behavioural and sensory responses. So this can lead to things like mental confusion, disorientation, dizziness, fatigue, and as a result, excessive exposure to dichloromethane within an area can potentially lead to death. So it is worth taking that into consideration. The other effects from solvents within the workplace, these are our chronic effects. So these are, generally speaking, you're exposed to small amounts of a solvent over many years, and then over time the effect may then happen. So you've got things like liver diseases, nervous system damage, dermatitis. This can also occur by maintenance activities, cleaning effects, and some of the common solvents that we've got within the workplace. So you've got benzene and trichloroethylene, which are known carcinogens out there. You've also got chloroethylene and dichloromethane, which are classified as suspected carcinogens. So there isn't enough evidence to determine that it is a carcinogen, but it is suspected as a carcinogen. And also NPB, N-propyl bromide, is known to damage fertility and cause harm to an unborn child. So what we need fundamentally is a suitable and sufficient cost assessment. This will show us how we can use this substance safely and put the relevant controls in place for us to work effectively and safely with that product itself. So what we do is we gather information on the solvent itself, and the way we do that is by various sources. So the first place we'd all probably look at is the material safety data sheet. So this will give us specific information about the substance, what the potential toxicology of the substance, any exposure limits, and how you should, it will give you pointers in terms of controls of using the substance itself. It'll give you, what you also need to understand is how the substance is used within the scenario. If you are working with degreasers, you need to understand the process and also think of the secondary tasks as well. So you do need to have cost assessments in place for the cleaning, spillage side of things, understand all the different processes that there are actually involved, because there is potentially high exposure within these activities. So say, for example, you are cleaning within a degreasing tank. Think how employees are exposed and the routes of entry. So we've talked about inhalation, ingestion, skin contact, skin absorption. Do understand all these routes of entry and make sure that is considered within the cost assessment itself, and also the extent of the exposure. So how much are you actually exposed to? The area, the vicinity, is it a well-ventilated area? Is it a poorly ventilated area? And then what you then do is identify what controls are required and apply the hierarchy of controls. So it might be the case that you add doors to a tank itself, or it might be the case that you have extraction. And if you do implement any of these controls, you need to ensure that they are regularly maintained. So the hierarchy of controls, as you can see, is listed over there. You've got elimination. So do I really need to be using this substance? Substitution. Are there safer alternatives out there within the workplace? The thing with substitution is you will look at other areas, but will it give you the same finish? Because there is a specific type of finish that you do require in certain scenarios. Then you look at engineering controls, things like your extraction, local exhaust ventilation, whether there is any lip extraction within the system itself. And then you've got your administrative controls. So this might be, say, for example, splitting shifts, reducing exposure time. It might also be the case of training. So these are areas that you do need to consider. And PPE, that is your personal protective equipment. This is the least effective control measure. It's worth emphasizing that point. PPE is always the least effective, and there's a lot of things that can go wrong with PPE. The emphasis is actually on the employee themselves in terms of wearing it correctly. If you are using respiratory protection, making sure that it is worn correctly. And we will be talking in detail about these points in the following slides. Elimination. Is cleaning, degreasing necessary? If it can't be avoided, then you need to look at alternative methods within the workplace. So, the three main categories that I've managed to find within industry. And first of all, you've got mechanical cleaning. So this might be things like sanding, blasting, dry ice blasting. And what we've also seen recently is laser cleaning and plasma cleaning is becoming more and more available within the workplace. There isn't much on there at this stage, but it is slowly being introduced within the workplace. So that is an area which could be considered going forward. What you do need to bear in mind as well is by introducing these different methods, same principles still apply, okay? So you'd still need to take into consideration the hierarchy and controls, make sure you have the adequate cost assessment in place, but also you need to understand the other health hazards and risks that are associated with those. So say, for example, I've got the example there in the bottom right-hand corner whereby someone is, using a grinder, for example, okay? So there will be other known health hazards and risks associated with that. So it might be the case that you need to look at the vibration side of things, because obviously that would be a hand-arm vibration problem there. So we'd have to look at things associated with that. You've also got aqueous cleaning, so this might be water-based. We have seen within various workshops that this is slowly being introduced. We've seen this within car workshops and sorts of places like that, where that has been introduced, and that has been quite effective. You do have different types. It might be acidic or alkali type solutions, but it is predominantly water-based. So that is moving completely away from the use of solvents. And then also you've got biological cleaning as well. So these are generally enzyme systems, bacterial systems as well. So these are being introduced as well. And these are quite useful for from what I understand, for reducing, for getting rid of things like fats and degreasing greases within systems themselves. And types of substances used here are generally things like terpenes and limonene type-based substances. Okay, so solvent degreasing, substitution. If solvent degreasing is necessary, what we should always try and do is, I know trichloroethylene and dichloromethane and some of the tetrachloroethylene, you get the finish that you require, but are there suitable alternative hazardous substances out there which are available to us which will give us that same finish? You should try and always look towards substitution. So what we're finding nowadays is there are modified alcohols, hydrofluoroethers, dibasic esters, ethyl lactates, petroleum distillates, which are being introduced, which are becoming more and more effective, and more organisations are moving to these types of substances within the workplace. But when you do switch to these types of substances, there will be some adjustments that you will need to make within the systems themselves. So things like boiling points. So certain solvents work at lower boiling points. Say, for example, dichloromethane works at 40 degrees centigrade. Okay? Some of the other alcohols will work at a much higher boiling point. So you'll need to ensure that all those adjustments are made. And also look at the safety devices. There will be cut-off points within these devices themselves. They will need to be adjusted. They may also introduce other risks. So there is also a fire risk. A lot of these substances, like petroleum distillates, are flammable substances, some of these alcohols as well, and you do need adequate precautions. So if you do implement any of these other types of substances, any of these other types of solvents, you do need to gather further advice from suppliers, and they will provide you with further information on, the boiling point and what measures you do need in place in those scenarios. If for whatever reason you can't substitute, you should look at enclosure, look at your engineering controls. Ideally, the best solution is to completely enclose the process itself, okay? So with trichloroethylene, for example, that should be used within a closed system because there are certain restrictions on trichloroethylene. By designing a closed system, it will minimize the emissions, minimize the potential exposure within the area itself, minimize the release, and minimize the spread of the vapor within the area itself. If, for whatever reason, you can't enclose the process itself, which you should try and always do if you can, you should try and enclose as far as reasonably practicable. And what you can do, say for example, if you've got an open top tank, for example, what you could do is retrofit a opening or door within the top itself. So that could be a simple way of reducing potential exposure within the area. You could look at tank lids. You can also incorporate segmented lids as well. So what that is useful on is like the long degreasing units, as they allow partial opening within the area for degreasing the smaller items themselves. Also, what you could look at is sectional lids or roller shutters, and these could be used when, say for example, you need an opening for when you drop down the degreasing components within the area. So you could close and open the process as and when required within the area itself. If you do incorporate lids, you do need to ensure that they are in areas which don't introduce a further hazard of that potential hazard itself. So say for example, you've got a degreasing tank, you've incorporated a lid, it's quite close to the rim ventilation around the system itself. Make sure that that is in an area which would not interfere with the rim ventilation. Obviously that would then reduce the efficiency of the extraction within the system itself. There are also other engineering controls that we can work with when looking at open degreasing tanks. So the cooling water supply. It's very important that you always have the correct flow within the system. Flow and temperature, okay? If this is set correctly, your system should work more efficiently. So in relation to that, make sure that you gather the relevant information from your supplier, because they will advise you on the correct cooling temperatures. Also, you've got the freeboard zone, and what you need to do within this area, this is basically the area above the open top vapor degreaser, above the cooling coils, which is known as the freeboard zone. And what you need to do is try and reduce the movement within this area. You will always get some movement from the vapor itself that's given off, which is being heated, and you will also get turbulence within this area if, say, for example, you've got an open room and you've got airflow within the room itself. So you do need to control this, and the way we do this is by having suitable and sufficient lip extraction. Okay, so that is the extraction around the top of the degreasing tank. You can see it with some small holes there within the picture itself. So that is a form of lip extraction within the open top degreaser. With the lip extraction, you need to ensure that it is suitable and sufficient. It will reduce, it will control the exposure to any vapors given off within the freeboard zone. And it needs to be regularly maintained. It needs to be properly commissioned. Okay, so making sure that it is working effectively when it is initially implemented. Once it is commissioned, it will require regular testing. So lip extraction will be required to be tested every 14 months, okay, as a minimum, as required by the COSH regulations. Also, other things to consider, setting of safety devices. So if you do have various sensors, cut-off points, this will reduce potential exposure, so the system will shut down as and when it hasn't been used for a certain period of time. It will cut off when it's reached a certain temperature. It will cut off, when, say, for example, controlling the sump level as well. So you should also look at water separators. If you do allow excess water to gather within a degreaser, it can cause the solvent to degrade, and that can then lead to corrosion. So it's very important that that is drained on a regular basis. It might be the case that you implement a pump system whereby it is piped out, and then that then eliminates the risk of someone actually doing the task itself, and it's done in a manner which can be done quite easily. And also solvent management, making sure you do have the correct procedures in place. I can't emphasize how much that you do always need to ensure you have good standard operating procedures, good cost assessments, and people understand those as well, okay? It's very, very important that people, it's one thing having all these procedures in place and these cost assessments in place, but people fundamentally need to understand the actual assessment itself. And finally, as you can see, remember, good design, operation, regular maintenance of degreasing plant can reduce operator exposure and improve efficiency and productivity. With fully enclosed systems, what is key is the loading, unloading procedure in place. What you can do is introduce ways in which you take out the degreasing components. So if, say, for example, you take out a part really quickly, that will increase the solvent within the area very, very quickly and very rapidly, increasing the potential exposure within the area. Or, and then also that can also create excess drag within the area itself. So what you could do in that instance is have a mechanical hoist, okay? So at a much slower speed. So if you take out the degreasing components out at much lower speed in a controlled manner, you're not going to be potentially exposed to large amounts of solvent very, very quickly. And also, it, again, eliminates the task of someone doing that manually, okay? So by engineering that out, and it again reduces the potential exposure within the area. Also, you should always allow for sufficient time drying within the freeboard zone. So once solvent has gone through the process, always allow sufficient time within that zone. Don't always take it out straight away, because that would increase exposure, again, very rapidly within the area. And you need to ensure that that solvent has reduced in terms of, the contamination of those components within the area as far as possible. Another process you should always avoid is also spraying within the freeboard zone itself, because what you'll find is vapor can remain within the area itself. I've also got a picture of a hand pump there. If you are solvent degreasing by hand, there are certain instruments out there within the workplace which are quite good, easy to use, and can potentially reduce exposure. So what you'll find is if you are using cloths and things, you can push directly on the hand pump itself. It will dose directly onto the pump itself, and then you can then apply. If you do use any rags or things, do ensure that once you do have cleaned the component itself, to put that within a labelled container. Other working methods that you do need to consider, so the clean out procedure itself, what you'll find is degreases can become contaminated with deposits and sludge. So with open top degreasing tanks, you need to ensure that you do have regular maintenance of plant, and you manage the solvents that you do use within the workplace. So if you do have solvents which you are constantly using, make sure that these are regularly cleaned. Also, this will improve the throughput as well, so it will increase the efficiency within the system. You should always consider the method of cleaning, and also entry into degreasing tanks is very important. So you are more likely to be in an area which could potentially be a confined space, for example. So make sure you do have your safe systems of work, permit to works, if you do identify it as being a confined space. The methods of cleaning as well, obviously make sure you do have an adequate cost assessment in place for the cleaning procedure itself. Make sure staff understand the cost assessment, make sure they understand the procedures, make sure they understand the method statements, and working methods as well. And also think about the process. So if you are adding or removing solvent in open top tanks, think of the potential exposure that could potentially occur within that scenario. Try and always engineer that process out. So as I mentioned earlier, you could potentially pump that out using a piped system. That would significantly reduce exposure. Also, a simple measure within the workplace, no smoking, eating or drinking, that could potentially reduce exposure to ingestion. That is always a good thing to have within the workplace. As I stated earlier, the use of RPE is the least effective control. What you should be doing is looking at substitution, looking at elimination, looking at your engineering controls, looking at administrative controls, and PPE should only be used with other controls in place. Okay? So, it will require careful selection, use, it will require maintenance. If you are using gloves, you need to ensure that you do have the relevant glove type. Certain solvents will break through gloves very quickly, so you do need to look through and understand the breakthrough times of the gloves themselves. Okay. Also, everyone has different hand sizes. Make sure that you do use the correct size of glove for that person. If you do introduce respiratory protection, there's a number of things that you do need to do with that, and that is for both non-disposable and disposable type RPE, you do need to ensure that the operative has been face fit tested. Okay, and also if you do introduce RPE, what we commonly see is RPE is readily available within the area itself. The filter type is incorrect. It's not protecting the worker to that potential substance. Okay, so making sure you always have the relevant filter media. And also what we tend to find is that it's not carefully stored within the area itself. So if you do introduce RPE, make sure it is stored safely within an area where it potentially can't be contaminated. Other things you can consider are air monitoring. So if you have to use a substance, what you might do is with certain substances, obviously things like trichloroethylene, benzene, obviously they are known carcinogens. Okay, so you need to ensure that you are as low as is reasonably practicable, well below the workplace exposure limit. So what you might want to do is conduct air monitoring, and air monitoring will be a way of understanding what you are potentially exposed to within the area itself. And it's a simple measure whereby someone wears a pump with a filter media, and then the airborne concentration is then measured. Other things to consider are biological monitoring. And basically what this does is it indicates how much of that chemical has entered into the body itself. And there's simple tests that can be done with this. So it might be a exhale breath test, it might be urine tests, or blood tests. Certain substances, dependent on the type of substance, there will be a particular test which will be used to see if that substance has entered the body itself. So what the organisation did was they did look to improve the system that they had, and this is what they bought. So they bought one of those, okay? And again, they were potentially exposed to trichloroethylene. When they implemented the system itself, there was actually lip extraction across the top, okay? And however, when it was implemented, it had never been tested, it had never been commissioned, they didn't know whether it worked properly, okay? Within the area, once they had degreased the components, what they did was, you see the table here on the left, they literally lifted the components up and placed this directly on the table. Again, no extraction within the area, no consideration of letting the solvent vaporize within the freeboard zone, literally up, across, and again, there was very little extraction within the area. So there was no general extraction, again, no PPE used or worn within the area itself, and obviously a large exposure to trichloroethylene within the area itself. What had happened was 6 months after the degreasing tank was installed, one of the operatives had started to incur breathing difficulties, chronic shakes, fatigue, and what the GP recorded was a 20% decrease in lung function. So, and then the HSE got involved, and we then prosecuted the organisation, and they were found guilty and were ordered to pay a fine of £9,000 and full costs. So, finally, what I've talked about today is understand the hazards, okay? What you need to do, know what potential hazards are incorporated with the substance itself. Is it a carcinogen? What are the potential effects? What are the risks involved with using the product? Okay? Look towards elimination, substitute wherever possible, and fundamentally always try and control the risks potentially within the workplace. Always look to enclose a process. Always look to include retrofit lids, for example, in open top tanks. Always look to try and enclose a process itself. So by taking these steps, you could make a big difference and try and work safely with solvents.
Thank you, Asif.